Hello and welcome again. Today we're looking at the infrared spectroscopy, which is a method that's commonly used in chemistry to analyze materials. In this video, we're going to look at how does IR or infrared spectroscopy work. And this is presented to you by Science Visualized. To start with, when you look at the electromagnetic spectrum, that's the EMS, or electromagnetic radiation, EMR, you'll see that the infrared radiation or infrared rays comes just after the UV visible, so ultraviolet and visible radiation. All the colors that we see are within the visible range. Infrared radiation has lower energy than the visible radiation. The energy of any electromagnetic radiation is given by E equals to h nu, where E is the energy of the radiation, h is the Planck's constant, and nu is the frequency of the radiation. The frequency of the radiation, nu, equals to c, which is the speed of light, divided by the wavelength of the radiation. Now, putting all of these together, the energy of the radiation equals to hc over lambda, where lambda is the wavelength. So we see that energy is inversely proportional to wavelength. Energy is directly proportional to frequency, and frequency is inversely proportional to wavelength. So the higher the energy, the higher the frequency, and the lower the shorter the wavelength. Now, how does IR spectroscopy work? You start with incident IR radiation coming in, and then that is split into two, where a fraction of the radiation goes through the sample that's being analyzed, while the other fraction goes through the reference. The reference sample is used to remove interference from the background. The sample will then absorb the IR radiation, and the absorption of the reference will be subtracted from the sample radiation, and the result will be the absorbance of the sample. So you can actually measure the sample absorbance. Or you could also measure the transmittance. Remember, the absorbance and transmittance are inverse. So the higher the absorbance, the lower the transmittance. That means the higher the amount of infrared radiation absorbed, the less amount of radiation transmitted. And we can relate absorbance and transmittance using this formula, where A equals to log of 1 over T, or you could say A equals to minus log of T. And the unit used in the x-axis of an IR spectrum is wave numbers, and the wave number is equals to 1 divided by the wavelength in nanometers. So for wave number, we have to change that wavelength to centimeters. Remember, 10 raised to 9 nanometers equals to 1 meter, and 1 meter equals to 100 centimeters. And lastly, the amount of IR radiation absorbed. So you measure the absorbance on the y, and then you plot it on the y-axis against the wave numbers. That's the frequency of the absorption on the x-axis, and that will result in an IR spectrum. You could also use transmittance instead of the absorbance, so the amount of the radiation transmitted plotted against the frequency in wave numbers. Please check the other videos on how to analyze IR spectrum. Thank you very much for your time. If you enjoyed this presentation, please like the video, comment, and also subscribe. Bye. Until next time.